Thank you. Thank you, everybody. Thank you for being here again. I know there are so many sessions, so it's pretty hard to choose. So thank you for choosing this one, first of all. I'm Alex Casalboni. I'm a technical evangelist at Amazon Web Services. And in this session, we're going to do some actual live coding, some actual application porting or migration, if you want. But we're going to use AWS Lambda, which is the function as a service offering of Amazon Web Services. But before I tell you about what I do, let me ask you a couple of questions. So how many of you already are using serverless or are playing with serverless or have serverless in production, either AWS or any other platform? Okay, a few. That's great. So thanks for coming, even if you already do that. And how many of you have an application that you would like to migrate or to improve or to migrate to serverless, like a Django or a Flask or another web application? So a few. So you probably have good questions at the end of the session. And of those, how many are Flask? How many are Django? How many are something else? What's that? Okay, cool. So I'm going to cover mostly Flask and Django because there are tips and tricks for those specific too, and then we're going to do a live demo, a live migration with a simple Flask application. So just to keep it simple and doable in 30 minutes. So this is who I am. I'm a technical evangelist, but that just means I'm a developer. Who is a developer here today? Probably 95%. Great. So that's what I do. I organize some conferences as well. There is a conference here in Italy called Serverless Days. I have a data science background, so I've done a bit of web and serverless and data science in the last 4 or 5 years, before in a startup and now at AWS. And yeah, it's good to remember, I was an AWS customer for like 5 years before I joined last year, and this is my 3rd time speaking at PyCon, so nothing changed really. It's just more fun. So this is the agenda for today. We're going to I'm going to share some background, because not everybody in the room has a clear idea about serverless computing and what it means and what's this cloud thing anyway. And then I'm going to tell you a little bit of history about AWS Lambda and Python together, what happened in the last 5 years since Lambda was announced. And then it's live coding. So 30 minutes, it leaves me around 10, 15 minutes of introduction. So most of the session will be coding. I hope you like that. If you need the slides, the link is there and you can download them anytime. If you need references or links, don't worry too much about pictures. I will share it on Twitter as well. So why serverless computing? It's been a bit of a buzzword in the last 4 or 5 years, but if you ask me about a year or 2 ago, how much stuff you can actually do on serverless with Lambda and other function as a service offerings, I would say maybe, I don't know, 40, 50%. Depends on the scenario, but if you ask me today, I would say more than 90%. Okay, there's been a lot of improvements. There's been a lot of tough decisions and very tough, incredible functionalities that allow you to do almost everything. Okay, NoSQL, SQL, web, IoT, data science. You can do almost everything in there. There are things like WordPress that you can't run on serverless, and that's a big chunk of the internet. But let's talk about that in another couple of years, and we'll see. So why serverless? The idea, the basic idea is that we don't want to spend most of our time with operations and with patching and managing and spinning up servers and machines. It doesn't mean there are no servers. Of course there are, and the cloud provider takes care of that for you. Okay, that means spinning up the server, installing dependencies in it, making sure it's up and running and patched with all the security vulnerabilities that come up every week, day, up to you. So there's a lot of heavy maintenance that you have to do to actually handle a server. If you have spin up a server and installed all the Python dependencies and everything to run your little Flask app, it's a lot of work. It doesn't mean it's not valuable work, but if you can take that and delegate it to someone that does it really well on multiple data centers and takes your application up and running with high availability, I think that's a pretty good value proposition. And since we take care of the cloud provider takes care of the infrastructure, it means we can make sure that your application is flexible. So if there is 0 request coming, you pay 0. If there are 1,000 requests per second, no problem, we take care of the scalability, elasticity for you. So as a developer, I don't want to think about that. We just write code, right? So how many of you are writing code and then whatever happens, it will go to production? I used to do that too, so don't be shy. Okay, everybody's shy, but most people do that. Most developers in their early career especially, we have done that, all of us. The git push and then something will happen and go to production. There is a lot that needs to happen. Actually, it's been estimated that most of the cost of an application is not writing code, but monitoring and keeping it healthy for the next 5 years. That's the cost for the organization. And patching and maintaining and so on. So high availability, flexible scaling, and pricing is pretty good. You don't pay for a server 24/7 if nobody's using it. You pay only per request. So I think it's a pretty good proposition. I've seen startups surviving for at least a couple of years using serverless just because they don't have this super huge load or throughput, and they can just say, I'll be serverless. If nobody's using my service for 3 days, great, I'll pay 0 for that, not a server, for those 3 days. And the other very interesting difference and advantage of serverless computing is that you can think about events, not necessarily about networking and processing or processes or protocols. You think about events. So when something happens, run this chunk of code. Okay, it's a different mental shift if you want, but there is a new object on your object storage, like an image. I want to process it. Great. Run this function when there is a new image on S3. Awesome. Or there's a new HTTP event or request. That's also an event. Run this code so you can do RESTful APIs. Or there is a new user signing up into my application with Auth0 or Amazon Cognito, like user management as a service. Great, run this chunk of code when that thing happens in the system. So you don't really have to code your full stack big monolith. You can just write your stateless, small, very easy to maintain functions that do something when something happens. So it's a kind of a mental shift as well. And then you want to use services like databases, managed services, machine learning services, just glue things together. And that's a pretty fast and efficient way to build applications now. Use cases, I'm not mentioning them all. We're talking about web today, and that's probably the most typical APIs and web applications. If you're doing IoT or mobile development or data processing or MapReduce kind of stuff, or chatbots, how many of you have an Alexa at home? If you're using Alexa, you are already using serverless. Okay, Alexa is built on top of AWS Lambda too. And if you didn't notice, it's in Italian now, so go and catch one. I have a few at home. It's also interesting that a region is coming to Italy. Just how many Italians in the room? Maybe half. Great. So might be interesting if you have data regulation concerns, or if you would like to have your data in country. In about 9 months, we're going to have a region in Milan. So it helps. For most use cases, it's not needed, but good to know it's coming. There is the best practice in the cloud in general is to do infrastructure as code. Okay, so you define your application in a template. It could be CloudFormation, it could be Terraform, it could be all sort of different frameworks and different things. At AWS, we use CloudFormation. So you define your JSON or your YAML template, and that's your application. So you can deploy it to an account or a region or a different environment like dev, staging, prod, and so on. For serverless, there is a specific kind of, it's not a dialect, it's a transformation that we call SAM. So it's a squirrel and it's a transformation of CloudFormation. So when you say, hey CloudFormation, this template is serverless, it will take it and do some interesting transformation so that you have more, let's say, more power. You can say this is a serverless function instead of this is a Lambda function, and it will just expand it to hundreds of lines of code. So what used to be 200 lines of code with CloudFormation now becomes like 15. Okay, that's more expressive power in your hands. So you can do stuff like, you can do stuff like define your serverless function. Here is the code. This is the runtime, like Python 2 or Python 3, or can I say JavaScript at a PyCon conference? Or JavaScript, or Ruby, or other things. and you define all the security policies and so on, and you deploy it to your account or region or whatever, wherever you need it. Another interesting thing of serverless I haven't mentioned yet is that if we want to have a dev and a staging and a prod environment, you know, those dev staging environments cost you 0 while you don't use them. Okay, that's really not the case if you have a 24/7 server running, like being used there, but only 1 hour or 2 hours a day for testing. So either you automate all the spin up, spin down, or you pay for it 24/7. With serverless, you pay 0. So you can even have one development account for each developer, and that will cost you 0, or you know, as much as the developer is using it during the day. I think that's also a pretty good way of thinking about it. A lot of customers and a lot of developers like to run this stuff on their machine, so we have developed AWS SAM CLI. It's a CLI tool that allows you to emulate and run Lambda functions and API gateway endpoints on your machine. It runs in a Docker container, but you don't see it. You don't have to build a Docker container or define a Docker image. But it's pretty neat, and we're going to use it during the live coding. So what happened about Lambda and Python? Little hard, because it's cute. And so what happened? So Lambda was announced in 2014, if I remember correctly. Yeah, 2014 as a preview, and there was no Python support back then. And then in 2015, Python 2.7, and then it took another year and a half, and Python 3.6, and then last year we announced 3.7. And then at some point people told us, hey, I want to have this minor version, and I want to have this nightly version of Ruby or Node. So what we announced is the custom runtimes. Oh, I keep losing it. Yeah, this custom runtime feature. Basically, you can build your custom runtime with your custom language support. So if you want to do, I don't know, C++ or COBOL, okay, or I don't know, what else? Or I don't know, really like any version or minor specific version of your language and libraries, you can now just build it. Okay, so we will keep supporting specific versions, major ones, of languages and runtimes, but you can bring your own. So there is no more, that's why I mentioned now it's 90% more of the use cases can run on Lambda, because there is no excuse anymore, it doesn't run on Lambda. It probably does. And it's even better because these runtimes can be shared from the community, from our partners, or if you want to build your own, you can just build it and share it, everybody can use it. So it's pretty cool. There are already runtimes for, sorry, it's a PyCon conference, but PHP and Ruby and COBOL, actual COBOL. So a bank migrated their mainframe code from COBOL to Lambda in like a week. So now they can run it in parallel instead of depending on hardware of a mainframe. So it's pretty neat. Great, so how do we actually port a web application to Lambda? There are a few shortcuts that you may want to take, and maybe you have heard of them. They've been around for a couple of years already. And one of them, you know, the easy way, let's try to cheat a little bit for now, then we do the actual live coding. If you want to cheat, you just install Zappa, init Zappa, and deploy in production. And Zappa is a framework that takes your Flask or Django or most other Python frameworks for web development, just wrap it and deploy it as a big function, like monolithic function to AWS Lambda. There is some configuration in that Zappa init, so before deploying, you want to check out that everything is there, like S3 buckets and stuff. But you know, this is the easy path, okay? Try that. If you already have a working application, you don't have to refactor anything, maybe 1% like configuration. Try that, why not? It's not optimal, it's not ideal because it's not, you know, you're not optimizing anything. The chunk of code that we're going to upload in there is probably 20 megabytes or something. So it's not even efficient or fast or a nice development experience. But it's a very good way, we call it lift and shift. You lift it and you shift it to the cloud and it works, usually. So check it out. We are not going to do this today. And zappa.io, so you can check it out and see if it fits your use case. If you have a Django or Flask application, it might work. There is another way to cheat. There is another framework called Chalice. or Chalice, I'm not sure. Chalice. So you install it, you do a little code refactor, but I'll show you how much code refactor it is, and you, again, Chalice deploy. The code refactor is basically that. Okay, let me show you again. That. Okay? If you're using Flask, this is for Flask. So instead of a Flask app, you have a Chalice app, kind of works. My personal suggestion, this works if you have a simple app that's doing some data manipulation or some other API calls or data aggregation. Probably a 15-year-old, no, 10-year-old Flask application with all sort of hacks and tricks might not work. So check it out. If, again, the easy path, the easy way to lift and shift. Couple, 3, 4, 5 endpoints. I wouldn't do it for a huge 30 million endpoints application. But it's worth giving it a try. Again, it's not enough. It's not enough at all. We want to build a fully optimized application that works for us and that scales horizontally, endpoint by endpoint. That's the microservices approach, right? So let's do it. Coding time. This is when I exit PowerPoint and we start coding. Let's do it. There is actually a repository on GitHub. Let's go back to the PowerPoint. This is the repo that I'm going to use. I have taken an application that's there. It's been there for like 6 years. So it's a typical legacy apps that nobody wants to touch because you might break it. And I've renamed it. The original name is like, it was running on Amazon Elastic Beanstalk, which is like a managed server management service, something like that. But it was running on a server. It's already using like DynamoDB and S3 and IAM like for permissions and object management. So it's still kind of cheating because I'm not taking a legacy app running in a data center. It's already running in the cloud. And I'm not, I'm being honest with you. If you want to migrate an app to serverless, taking an app that's already in the cloud would be easier, of course. If you take an app running in a data center or on your machine, you know, it's not cloud native or cloud ready, so it might take you longer. Today we are doing the hard path, but still kind of the easy path, because we are taking an app that's running already in the cloud. So let me show you what the app looks like. Yeah, so this is the app. There is an application.py, everything is in a file, so it's nothing impossible to read and refactor in 30 minutes. It's even using the old Boto. Boto is the AWS SDK for Python. And now we have Boto 3, which is the new version. So we will also upgrade to Boto 3 because that's what comes already built in AWS Lambda. You don't have to install it or package it or anything. It's already there. So we'll migrate. We'll upgrade the version of Boto as well. There is some configuration stuff. And then some connection to the cloud stuff. There is a route, which is an HTML page. Okay, usually in the modern, let's call it modern web world, you don't want to have HTML pages in your server side processing stuff. So you probably want to separate front end from back end in a client side project and a back end side project. So we're going to do that as well. We'll take this HTML page, we'll make it static as a static website, and we upload it to S3, and we'll serve it from S3. We are going to take this route. This is the only other route we have. And it's a sign up. Let me actually show you what the application looks like. Clear, Flask run. So this is in Flask. I'm now running it from my machine. Okay, that's the application. It's a super stupid landing page with a sign up, with a form to get like preview access to a startup product. So I can do something like I'm Alex, I'm alex.test.com. Do you want preview access? Sure. And I sign up. Takes a while. Does it work? Still works. Yeah, works on my machine. So what happened is that now the request went to the cloud, and I probably got, some people are texting me, but I should get an email at some point. Yeah, so that's the application. It's taking some data as a preview form, and it's sending me the data via email. Nothing crazy, right? It should take an hour, to develop this, 2 hours. So in the next 20-25 minutes, we'll migrate this to serverless. It's not that crazy. Let's look at the code. Yeah, so there is a backend sign-up route that's taking the data. So the sign-up data, the form is converted into a dictionary. It's storing the data into a DynamoDB table. Let me show that to you as well. So there is the DynamoDB table. If I refresh, DynamoDB is a NoSQL database. So now I have this NoSQL record. The key is the email, so I don't have duplicates. And I have, that's my data, my item. So it's writing the data into DynamoDB, and it's publishing the same data into an SNS topic. SNS is a simple notification service. If you publish a message there, it's like PubSub. You publish there something, and then you can connect listeners or subscribers. And as a subscriber, I subscribe my email. So I'm getting those notifications via email. Simple. And that's the application. If there is a conditional check fail exception, that means if that email already exists, respond with a 409 message, which is like already existing, instead of a 201 message, which is created. Okay, just a little RESTful logic. And then the store in Dynamo and publish to an SNS code is like 10 lines of code. And then we have the template, which is a very simple HTML page. There is some backend processing, like URL for, that's what you do in Flask. But other than that, it's basically 15 lines of JavaScript, taking the data, posting the data to the backend. Okay, simple. Questions so far? Good? We are all on the same page. So the first thing we're going to do is to remove the server-side processing stuff from this HTML page. So we can have a static website and a serverless API that is serving that static website. So let's do that real quick. We don't need all this URL for. Let's remove it. Let's also remove, the final. Great. So I don't have any dynamic Jinja stuff. This is considerable a static page, and the JavaScript. Okay, the JavaScript code is posting the data to a /signup page. So the assumption here is that the backend is on the same domain. Okay, since we're going to have a static website on S3 and a serverless API on Lambda and Amazon API Gateway, they will be 2 different domains. And so we'll need to manage cores, and we'll need to manage, a prefix here. We want to add a prefix. So the prefix we may want to make it configurable. We don't want to our code an API URL here, right? So let's do something like this. Let's add one more file. Could be like config. This is a simple way. I'm not using React. I'm not using Angular. I'm just doing plain simple stuff, so everybody can follow without issues. So first of all, this file is in the templates folder, and we also have a static folder with all the static file. So guess what we're going to do? We're going to move, kill Flask. We're going to move the templates file index into the static folder. Good. Now we have a static website in the static folder. Done. And we can do remove dir template because we don't need it. We're good. So we're going to need that config file, static config.js. And in this JS file, we are going to do something like, var config API something. Okay, my API prefix. And at some point we will have it and we'll be able to use it in our application. Cool. So it's not there anymore, and we have index, and it's linking to config.js. Well, good. So how do we make this a static website? So I have already created a bucket on S3 that I called serverless sign up. So I can just say, put all this stuff into the bucket. So I'll just do AWS S3 sync from the static folder, to S3 bucket, and I'll do ACL equal public read. So it's a public readable data on S3 bucket that we can serve to the internet. Does that work? My memory is really bad, so I'll go to the documentation if stuff doesn't work, and it looks like it's working. So if it worked, here I already have my website. Okay, that took us 3.5 minutes, 5 minutes maybe. And it's already working. The UI doesn't depend on the server. Of course, if I click sign up, there is no server responding at this domain. So we'll need to now go and create the API. Okay, front-end refactoring, done. It takes more than this in real life, but for now, done. And we'll need to update this configuration file. Let's go back to the backend, the real meat, the real stuff. So there are some things that we are not going to need. Guess what? We don't need Flask, and we don't need Boto 2. We'll need Boto 3. So let's import Boto 3, and we'll need some Boto 3 resources. But basically, all of this stuff is not needed. We'll need some environment variables. So this app is already configured to read some environment variables like the name of the table, the DynamoDB table, or the name of the topic to send a notification. So this is already dynamic based on the environment. So we are in good shape. And we can do table name, OS environment of this, and SNS topic, OS environment, and it should be somewhere down here. Yeah, new sign up topic. Great. So we will read that from the environment, and of course Lambda supports environment variables. So we'll be able to inject those environment variables into the Lambda runtime. All this stuff can just disappear, and we'll just create the Boto 3 resources in a second. This route, again, can disappear because we moved the front end to some other system. And this code is roughly what we need. Okay, this is not needed either. And this can just be a print. Good. So there are some things. There is no app anymore, and we don't need an app. So first of all, we need to create some Boto 3 resources, and I've already shared with you that my memory sucks. So I'm going to load it. No, actually, I can read it from the documentation, so it's easier. So we'll need a DynamoDB table. So we can just copy that from this is the official Boto 3 documentation, and unless you are really good with memory, you will just do this. You will copy it from here, and you'll customize something. So we create a DynamoDB resource and the DynamoDB table, and we give it the table name. Nothing crazy. We are using the SDK here to talk to the cloud. And then we'll need the SNS SDK as well. Client, how do we create a client? Yeah, that's how you create a client. So we copy that as well. Great. So we'll be able to do client.publish down here, and we'll fix that later. So there are a few errors here and there. Why? We don't have the client anymore. We don't have the app config anymore. We don't have this stuff anymore. We don't have the response object of Flask anymore. So we need to do some refactoring, right? So this is good enough already. We need to add an event and a context. This is what Lambda gives you when you invoke it. It gives you the event, the HTTP request, everything, the headers, the body will be in this event variable, and the context contains some information about the current invocation, like the identity, how much time you have left, and stuff like that. We don't have the debug anymore, so for now let's skip it. Of course we can inject a debug variable and do the same stuff, but let's move quickly. We don't have request. So in Flask you have this global request magic object. We don't have that, but we have everything inside the event. So if I do event body, guess what? We have the body of the request, and it's a JSON object already. It's actually a JSON string, so I don't need to JSON dump it. Sign up data, I don't need all this stuff. I can just do JSON.loads event body. Good. So I parsed the body of the request into a JSON object. Nothing crazy. Store Dynamo, publish to SNS. There was some error checking, because if the email already exists, we are going to have this conditional check failed because the email is already there, and maybe you want to give a different message into the UI, like, hey, we've got your email already, thanks. And that's why we were returning a 409 error. Let's take care of the response first. So let's do like def response status message. So we'll do something like return status code status and body JSON dumps message. Good enough? This is what API gateway needs from Lambda in order to return a proper HTTP response. So you just give it a status and you give it the body. There are a lot more parameters and arguments that you can give, but for now it's good. Yes. So here now we need to handle this conditional exception. Actually, we have changed the Bodo version, so we are not actually doing it the same way. And again, my memory sucks, so I'm going to copy this stuff from here. So the way you do it with the new Bodo is that you import this exception. It's a client error, and Bodo will raise a client error here. So accept client error as X, and if the response error code is conditional check failed, we are going to do what we used to do before. Okay, so just a little syntax change here. I'm not really porting, I'm just upgrading. And I'm going to do 409, and I'll say okay, because it's still okay, right? And works, yep. If everything went fine, I'm just doing response with a 201 status and a okay response as well. There might be other exceptions, so let's do except whatever happens here, return. Okay, let's print it first because debugging is very useful. Yeah, come on. And then return response, whatever, it's internal server error, but without the servers, and KO. Cool? Pretty much the same logic we had before. We have changed the response object, and we have changed some conditional error stuff. Now, we need an E here, and we need to upgrade this stuff in Dynamo. So the way you do this stuff in Dynamo now is we do table dot put item, and we do item sign up data. Sign up data. Cool. So this is just slightly different, but this is the Boto 3, Boto 2 difference, not a serverless migration difference. So let's not spend too much time on that. And SNS, we're going to do client.publish. Okay, again, my memory sucks, so let's go here. Let's find the publish method. And this is how you do SNS Publish. So we need topic arn, which is just the name of the topic. And we have that here. Done. And we're going to do message and subject. So message would be just JSON dumps of the sign-up data. So I'll get the same email as before. And subject can be new sign up. And you can put all sort of emojis there too. But let's not do that. And we are handling the exception up there already. So all of this is gone. So we started with roughly, am I good? Yeah. We started with 80 lines of code, and we ended up with 68, almost 70. So we even shrink the code a little bit. That means less code to maintain, less code to review, and everything. So happy teams. Okay, and if we just were about migrating the code, we'll be done. But now we also need to deploy this stuff. Okay, Beanstalk, Elastic Beanstalk will do this stuff for us. You just provide the repo, but now we want to deploy a serverless application. So the way you do it is you create a template.yaml file, and in this template you define everything. You define the function, you define the topic, the database table, the permissions, and so on. So we already have some of the resources up here, because this was the Beanstalk that the Elastic Beanstalk stuff that define the topic and everything. So we're going to reuse that because we're lazy, of course. And then we need to define our Lambda functions too. So let me go to the AWS documentation. This is AWS, it's all on GitHub, so you can contribute to it, you can report errors and so on. And if we want to just define a function, first of all, we define the transformation. So we'll say, hey, CloudFormation, this template is serverless. Just treat it as a serverless template. So first of all, we define the transformation up there. And then we can define a function like this. So let's go to its sign up function. It's a serverless function. We don't need all this stuff. Here you define where the code is. Okay, our code is inside a backend folder and application file, and it is a sign up function, right? So I think I can say code URI, yeah. So code URI will be the folder. Oops, sorry. It'll be backend. Handler will be file name dot function name. That's standard stuff. So it'll be application dot sign up. Correct? Correct. Runtime, it's not Node, it's Python 2.7. And we don't need that. Okay. And then what's all this stuff doing down here? So it's defining a DynamoDB table that we're going to use. It's defining the queue and the topic for SNS and SQS. Here you can put your email. So I can say alex.alex, whatever, don't spam me please, .com, blah, blah. In an ideal world, we will need to add here some permissions. So you want to give your Lambda function specific granular permission only to write into the DynamoDB table, but not read, and only to publish into SNS, but not create new topics. So you can do that. You can say very, very granular permissions. And how much time we have left? 3 minutes. So after this, you do that, and then you do AWS package and AWS deploy, which are the two steps to take all your code, bring it to the cloud, and then take that artifact and deploy it to Lambda. There are two very like 10-second steps via the command line, and your function is up and running. I don't want to annoy you, and I want to be late. If you want everything, let me give you a pro tip. Everything is already on GitHub. Okay, if you go to that repo in the pull requests section, I've opened a pull request with the porting yesterday because you prepare for your presentations. So you can see everything that we have done there, and with some more magic as well that I didn't want to bore you with. Okay, so if we have questions, we have 1 more minute, and thank you for coming.
There is time for one question.
Thank you. I want to know how can you keep sessions and permissions based on authentication?
That's a good one.
Okay.
So session in general, I think that's the best practice in general. You want your APIs to be as stateless as possible, so you can have multiple servers and they can go down and up. So the idea is that you store the sessions and everything into some other service. It could be DynamoDB, it could be Redis, it could be your, don't do it in a relational database, but it could be anything. But don't store it in the memory of the function, because that might be taken down, or you cannot have sticky sessions anyway. So don't use the RAM or the local file system. That's highly not recommended. So use any other sort of third-party tool or service or framework to do that. And that's a recurring idea in serverless. Delegate and focus on your core logic. And about authentication, same. Okay, you don't re-implement. How many? Okay, who has implemented authentication more than 3 times in your life? 5 times? 10 times? I'm probably around 15 in my life, and I want to do any more. So I use a service for it. It could be Amazon Cognito, it could be Auth0, it could be all sort of services that do that for you. Multi-factor authentication, password emails, everything you want in a checklist, and you don't have to re-implement it. encrypt everything and secure everything, and that's my suggestion. About authorization, you have all the tools in API Gateway and Lambda to say, okay, this identity is mapped to this role with these permissions, so you can call this API but not this other one. So you have, I'm going to show it to you, but you can be very granular and have an admin role, a regular user role, and anonymous user role, and they can do different things in the system. Make sense?
Thank you,
everybody.
Alex.